Welcome back, and we notice that when the water tap is on, the water flow and turn the turbine. The turbine will rotate the coin. Once the coin rotates, the coin cut the magnetic flux or cut the magnetic field lines. The current induced in the coin, which from 0 to maximum. Okay, one is maximum. Notice that the coin is in vertical direction, where the area is parallel to the direction of the beam, maximum. Okay, and maximum opposite direction will be when the coin facing to opposite side. So the current induced, the magnitude is from 0 to positive maximum, back to 0, then go to negative maximum and back to 0. This pattern of the current induced, the graph shows that the current induced in the generator is alternating current. So alternating current generator induce or produce the alternating current source. Now we observe that. The next slide. From the observation just now, step 1, the guidance flux at time t. The flux or the density of the magnetic flux is equal to BA cos omega t. According to the Faraday's law, EMF is equal to negative rate of change of the flux. This means that, still remember or not, the current just induced when there is a change of the magnetic flux. Remember the 3 types of change in the magnetic flux. First, by method of cutting of the magnetic flux. Second, will be change of the strength of the magnetic flux, become stronger or become weaker. The third type will be the change of the direction of the magnetic flux. That means change of the magnetic pole. By substituting the flux, the formula of flux equal to BA cos omega t into the formula of Faraday's, into the Faraday's law, we get that EMF is equal to negative d over dt BA cos omega t. Differentiating, that means make the differentiate, we notice that we get that the EMF is equal to BA omega sin omega t. Ladies and gentlemen, if the coil is made up of n turns means that more than 1 turn. Just now we just observed the 1 turns of the coin. What happened to 1 turns of the coin in the magnetic field? Then the flux through the coin should be n times of that of a single turn. Then the total flux through the coin is n times with the flux, magnetic flux. As a result, the total induced EMF will be equal to NBA omega sin omega t. Just the single coin, the EMF produced by single coin times with the number of turns. How many number of coin? So just multiply, just time with the how many turns of multiplication. As a summary, we can set that the flux linkage through a coin is flux equal to N times with the magnetic flux through a single turns. That means that magnetic flux, magnetic field line through a single turns. How many magnetic field line that pass through the turns, the area of the turns? The EMF induced in a plane coin is maximum when the plane of the coin is perpendicular to the magnetic field lines. The EMF produced by an AC generator is given by EMF equal to NBA omega sin omega t. For this which is turning, we must use the omega where it is angular velocity. Now, ladies and gentlemen, please observe that if there is an EMF, that means that this one we provide, okay, we want to find out the back EMF. Once the switch is on, we on the switch, we notice that the coin is rotating. Okay, the coin is rotating. Where the coin rotates in a uniform magnetic field, where this will be North Pole, left side will be the North Pole, right side will be the South Pole. This coin can turn when we provide an EMF. We provide the electricity and cause the coin turns. Where this show that this will be a motor. Okay, so from the derivation, the net EMF will be equal to the EMF minus the back EMF. Using Ohm's law, I equal to V over R. That means that the current will be the EMF. EMF will be the voltage provided by the source minus to the back EMF. That means that the voltage which opposite or against the EMF, against the voltage produced by the battery. So, ladies and gentlemen, for an example, when a motor is turning, I give an example of a, let's say the fan. Now we are at home. Surely, beside us, maybe there's a fan. Now I'm using a fan. Observe that when the fan is on, the fan is turning, right? The fan is turning. When the fan is moving, the back EMF produced actually is very, very small. What happened if I on the fan, but I force the fan to stop? I use my hand and block the rotation of the wings. The switch is on, which want to cause the fan turning, but I use my hand, stop the fan, block the motion of the fan, where the current flow through. At this moment, the EMF will keep on increase. Once the EMF increase, which is equal to the EMF or higher than the voltage produced by the or provide at the end, pole of the fan will burn. That means we spoil the fan. If the fan is turning, no matter how long we on it, we switch on, don't worry, the back EMF is very small and it will not spoil the fan. But once we block the motion, then we will spoil the fan in less than 1 minute. As a conclusion, when the coil of a motor rotates, a back EMF, a back voltage is produced. A voltage is produced where the voltage is in opposite direction and against the voltage we provide. So that means there is a back EMF. The back EMF is directly proportional to the angular velocity of the coil. And the current in the motor is given by I equal to EMF provided minus to the back EMF over the resistance of the motor of the coil. Ladies and gentlemen, that's all for today's lesson. As usual, later I will post the question for today's lesson to our Telegram group. As usual, I want you all to try out the question first, solve the question first before we discuss. You can check the answer, which I will post it after the question. And here will be the question for today's lesson. Question number 1. Question number 2. Question number 3. Question number 4. Part of the question number 3, yeah. Question number 4. Question number 5. Question number 6. Question number 7. And last, question number 8. So that's all for today's lesson. Ladies and gentlemen, before I end the lesson, do you have any question you wish to ask? If yes, you can on your mic and ask the question. If no, please let me know. Okay, so that means no question, yeah. Okay, so okay, so if no question, so we stop our lesson and please download the question from our Telegram group and solve the question. Thank you very much and see you on the next lesson on Sunday. So thank you, my student.